Metals are recycled because they are valued and because most of them share the inherent quality of recyclability. This is especially true of non-ferrous metals, a group that includes this: the big nickel. Nickel is amongst the most valuable of common non-ferrous metals such as aluminum, copper, zinc, and lead because of its good workability property. Nickel is often plated to other metals as a protective coat to provide wear resistance. Nickel can be seen in industrial and consumer products, including stainless steel, magnets, coinage, batteries, electric guitar strings, and many more. But where does nickel come from? There are two sources of metals. One is from minerals and ores, which can be a long talk if you want to know more about this. And second is from recycled materials. Tantalite mineral is the primary source of nickel. The ore is mined and then it undergoes physical processing to obtain the concentrate. The concentrate then undergoes chemical processing to extract the metal of interest. Nickel can also be obtained from recycled materials, such as those generated during the production of metals or home scrap, manufacturing of metal articles or prompt industrial scrap, and those obtained from manufacturing which are no longer useful or obsolete scrap. Recycling nickel is such a tedious process, but the value that you get from doing it is worth all the trouble. Presenting the step-by-step procedure of battery recycling. The recycling of batteries starts with the sorting of the batteries. Batteries of varying chemistries such as lead acid, nickel cadmium, nickel metal hydride, and lithium ion are placed into designated drums, sacks, or boxes. After sorting, the combustible material in the battery, such as plastics for insulation, are removed using gas-fired thermal oxidizers. Scrubbers are then used to eliminate the polluting particles created by the burning process from the previous step before releasing them into the atmosphere. The final product in this step is a naked cell with the valuable metal content. The next step is melting. The cells are cut into smaller pieces and heated until the metal liquefies. Non-metallic substances burn off and leave a black slag on top that the slag arm removes. Melting the cells causes the alloys to settle according to weight. In order to store the schemed molten metals, they are then poured directly into what the industry refers to as pigs or hogs. The pigs, hogs, are then shipped to metal recovery plants where they are further refined and purified such that the final product could be ready for use once again. Eventually, the recovered metals would then be used to produce nickel, chromium, and iron for stainless steel and other high-end products. Recycling of automobile scraps is much more labor-intensive than the recycling of batteries since it involves bigger chunks of metals. An estimated 40 million end-of-life vehicles or ELVs arise annually. The metallic components of these vehicles are largely recycled, but up to 10 million tons per annum of non-metallic waste remain unrecovered worldwide and are generally landfilled, wherein a small proportion is incinerated. Once the automobile becomes an ELV, Its parts are to be dismantled and distributed to auto recyclers, salvage yards, scrap metal recyclers, and dealers. Reusable parts and CFCs are sorted to be sold to appropriate buyers, while the non-metallic waste, such as the tires and fluids, are sent for disposal in landfills. The metallic waste then undergoes shredding. After shredding, the non-ferrous metals, like nickel, could be extracted from the waste using high-tech sorting machines that perform magnetic separation. The non-magnetic non-ferrous metals would be further separated using eddy current separators, which make use of powerful magnetic fields that induce eddy currents. The magnetic ferrous metals would then be separated to be sold to dealers. Finally, the separated non-ferrous metals would be sold to dealers or sent to metal recovery plants to be used in the industry once again.